Hi, CC2. Today we're going to be talking about how to solve one-step equations. Our essential question for today is how do I solve one-step equations? So, our first question that we are going to ask is solving one-step equations method. What is the method that we use? So, in order to solve one-step equations, you do the inverse operation of what is being done to the variable in order to get the variable by itself. So, really quickly, let's go over inverse operations. So, the inverse operation of addition would be subtraction and vice versa. The inverse operation for multiplication would be division and vice versa. So if there's a problem that's already adding, you're going to subtract. If there's already for subtraction, then you have to add. Same thing with multiplication and division. If you have to multiply, if it's already multiplication, to do the inverse would be division. The inverse of division would be multiplication. So let's see what this looks like in our examples. So let's say that we have the equation x minus 13 equals 13. So what you're going to do is, because the original problem is subtraction, instead of subtracting, we're going to do the inverse operation, which means add 13. So our variable are our letters in each problem. So remember, our variables does not always have to be x, doesn't have to be y. It can be r, it can be g, it can be q, it can be any letter. So as long as whatever is the letter, that's your variable, and you want to get everything away from the variable. So the opposite of subtraction was addition, so we're adding 13. Whatever you do to one side of the equation, you have to do the other side. So if you're adding 13 on the left side, you also have to add 13 on the right side. So then x minus 13 plus 13, you're just left with x, so that's alone. 13 plus 13 is now 26. And then if you want to check your solution, you can put 26 back in for x, and you can say 26 minus 13 and see, does that equal 13? And you see, yes, it does. So that is correct. So that x equals 26 is our final solution. All right, let's try the problem to the right. 15 equals 5. And remember, when you have a variable right next to a number with nothing in between it, this is multiplication. So 5 times y is equal to 15. So we need to figure out what is y. So if we are multiplying in our original problem, we have to do the opposite operation, which is division, like we set up here. So remember, we're going to use our fraction bar line as our division symbol, and we're going to divide by 5 because we want to divide by the number next to the variable. And then we're going to divide by 5 on the left side because that's what we did on the right side. 15 divided by 5 is 3. And then 5y divided by 5 is just y. So that's alone. So now y is alone. So then if we want to quickly check this, we can say, does 15 equal 5 times 3? Yes, it does. So that works. 5 times 3 is 15. Let's do the next example. So this is y divided by 8 is equal to 2. So this is a division problem. So the opposite of division would be the multiplication. So since y is being divided by 8, we have to do the opposite to get rid of the 8 by multiplying by 8. So on both sides, we're going to multiply by 8. And when you multiply 8, this will become 8y divided by 8. So these 8s are going to cancel each other out because this is like saying 8 divided by 8, which is just 1. And then your y equals, and then 2 times 8 is 16. And then to check the solution, we would see the 16 divided by 8, does that equal 2? And it does, so that's correct. So then our final solution would be y equals 16. Up here, yeah, that's our final answer. So then let's do 2r equals 22. So this is in a multiplication problem, just like we saw right here for the 5y. So the opposite of multiplication would be division. So on both sides, we're going to divide by the number next to the variable, which is 2. So then 2r divided by 2 is just r. And if you look at what this ends up making, and for CPM, we know this as a giant 1. So you know if it's 1, you're just left with that r. So that's another way to look at this is a giant 1. Same thing here. This ended up being a giant 1. So then you're left with r equals 22 divided by 2 is just 11. And if we wanted to check this, 2 times 11 equals 22. Is that correct? Yes. All right. The second to last problem, we have 16 equals 3 plus g. So this is written a little differently because there is no plus or minus in front of the 3. So you look at if the number is either positive or negative. When there is no negative symbol, you can assume that this is positive. So you can assume that you're adding 3 here. So because this would just be adding 3, the opposite operation would be minus. So to get rid of this 3, we'd have to subtract 3 from positive 3. And then if we subtract on that side, we have to subtract on the other side as well. So then 16 minus 3 is 13. And then you're just left with g. And if we want to check it on the side, we can see does 3 plus 13 equal 16? And yes, it does. So that's correct. And then for our last problem, we have 11 equals w divided by 4. Remember when you have a number over a number 4, when you have a variable over a number, this is division. So the opposite operation would be multiplying by 4 on both sides. So we're going to multiply by 4. So then remember when you have a 4 over another 4, this cancels each other to make 1. So then you're just left with w equals 4 times 11, which is 44. And then that would be our final answer. And if you want to check it, you would say is 44 divided by 4, does that equal 11? And you can see that it does. So then that's correct. So in summary, the essential question was, how do I solve one-step equations? So our summary would be, you solve one-step equations by doing the inverse / opposite operation to both sides of the equation. So if I went too fast during the problems and the examples, please feel free to rewind and go back and double check. I would like for you to try some of these problems on your own. There will be a worksheet that you'll be doing following this. Thank you.